Okay, this is just kind of for Jared. Um, and sorry to get you guys distracted. Sometimes I just get things out of my chest, make me feel better.
Can you go on to the next screen?
Huh? Okay.
You know it's mental health month.
Yeah, it's my mental health.
No,
It- No, it isn't. Isn't it June?
I just made that up. I think it's both.
It's both of them. Yeah.
All right, so I hear at a time zero. So I was talking to last period too. Is there was something called Newton's Corning law. Newton's Corning law is to study like when Newton, like when you're trying to boil a tea, and then he kind of look at the tea. He say, okay, well the temperature is going down. Obviously, the room temperature is way below the tea temperature when you boil them, and then so at first, because there was a big differential between a room temperature and the tea's temperature. So at first, the temperature is going to go down a little bit faster than normal, and then when you get to I think it's the other one way or the other way, but it's gonna it's gonna decrease a lot faster. But then when it comes to room temperature, it kind of plateau into that. So it's gonna plateau into room temperature, which is 27 degrees. And this is a question that at 2017, everybody take the test. Then like a milk question. When they come back to me, it's like, Mr. I have no idea how to do this question. It was a potato question. And matter of fact, that year has a meme on the internet because the average score on this FRQ is 0 out of 50% have a 0 out of 9, and all the total population, the average is like 1.4 or 1.8 out of 9. All other question has an average of 4 to 5. This one is like 3 point less. And the reason why they are 3 or 4 point less is because the question is written in a very funny way.
Would they drop the question?
No, they just curve them. So there was a things that you are gonna worry about is t. T, well, I hear we're gonna say t is equal to time, but there was also temperature start with t, right? So temperature, and people thought that's t as well. So they get confused with two different t because they didn't know what an independent variable or dependent variable is at this situation. So like a Bayer question was easy to manage because B of t represents population at given time. This one is the temperature at given time. So people plug in the value, plug in the wrong. They plug in the 0, 0 for the temperature and plug in 91 for the time. So that's what the main problem that was created on this question. But this question is very famous in calculus called Newton's Coulomb law. Now the actual differential equation is a little bit different than this one. So at t equal to 0, the boiled potato is taken from left of the quote in the kitchen, and this is somewhat important. This temperature at 90 degrees at t equal to 0. That's initial conditions. Internal temperature is greater than 27 degrees, so you're not gonna have potato get cooler than the room temperature. It doesn't make sense. It cannot be a potato is 2 degrees and room temperature only 27 degrees. So they kind of had to state that. They had to say it's greater than 27 degrees at all time, t equal to 0. Because sometimes you live outside, potato the temperature could have dropped below 27 degrees if you're in the north state. Um, and they say internal temperature of potato at time t minus make a model a function h that satisfies the differential equation dh dt equal to negative 1/4 h minus 27. H of t is measure, so h of t, right, is a measure in degrees Celsius. So h of t is the temperature. So h of t is the temperature. Now the t equal to time. So that's what is confusing about. So then you say, okay, well, write the equation of giving time. So usually it's y minus y1 is equal to m times x minus x1. Now, at this case, it's going to be y is going to be h of t. minus y1, which is the temperature at 91 degrees. Does that make sense? Because this is 0 comma 91, so that is going to be minus 91 is equal to m times, well, this is t, not x, and then minus 0. Is that okay? So then h of t is equal to mt plus 91. What is m? How do you find m? Jared? Yep, dh dt. When h is equal to 91, so that's going to be negative 1/4 and 91 minus 27. So that's equal to negative 1/4 times 64. That's equal to negative 16. So h of t is equal to negative 16t plus 91. So they say use the equation 9 to approximate the initial temperature when t equal to 3. All you got to do is plug in 3. And that becomes the evaluation. And I believe that's 43. I'm not sure. But that's 40 degrees Celsius, I think. Yeah. Is that okay? So the first answer is 43. You had it wrong.
I think I did what you were saying. I did t minus 0 equals. But I also did got the derivative wrong.
Okay, so now do you know how to do it? Okay, so we're gonna go to bar B. They say use d2h dt squared. So a long time ago, when we teach teach the second derivative on implicit, we says, well, dh dt is equal to negative 1/4 of h minus 27, right? And can I just say d to the dt again, which is second derivative, which is d2h dt 2. And that's equal to, well, I'm going to go ahead and distribute that so that makes my life easier, because 27 over 4, when you take a derivative, is going to go away. So that's going to be negative 1/4 and then dh dt. And when we're doing this, the implicit derivative for second derivative, we usually plug in the first derivative into the second derivative, because this is dh dt, right? Can I just do negative 1/4? And dh dt, I'm just going to go back and substitute again. So it'll be negative 1/4 times h minus 27. And since that distribution, that's 1 over 16, h minus 27, and d2h dt2. Now you can plug in 43, which is the temperature that we estimated before. But the truthfully, it doesn't really matter what temperature you plug in. You know, your potato doesn't matter, it's 91 or 43. It doesn't matter what temperature you plug in. The result is always positive, right? The temperature is always greater than 27. So dH dt has to be positive. Am I okay? So that's the positive here. Now the positive is concave up. Is that overestimate or underestimate? Why do they ask you second derivative to ask you is overestimate or underestimate?
Underestimate.
Why is under?
Going to be under the curve.
Exactly, the tangent line. And that's why I thought the definition of the concavity is better to base on the tangent line, because tangent lines below, that's where it's concave up. Is that okay? So it's under approximation, so you should write down under approximation. And they should ask you justify, then you say it's concave up. Yeah, that's it. This is concave up.
So I know why it's an underestimation, but so like, but a point is still a point though. Like it crosses that t equals 3. Like it hits that t equals 3.
Yeah.
So why does it matter like that the line, all the other parts of the line are below it? Like, isn't it like, say if you had t equals 5, you'd make a new line. Is that, I don't know.
So there was an actual thing.
Because I feel like we're not looking at those other parts of the line. We're just
You just look at the specific part right here.
yeah,
Okay, so look at this part, right?
yeah. That should be it.
It's gonna be, this is the exact situation. This is the approximation, right? So because tangent lines are approximation, they're not, we just look at the microscopic part of that. So they are just saying at that region, at that small region, are they over or under? At that particular point, may not be, it's still gonna be under though. Because you are talking about this is the actual, this is the, if you approximate from, let's say 2.9, then your tangent line is still gonna be below. So the whole way is gonna be below. So there's more likely to be under approximation. And at particular point, because your tangent line is already approximation,
Okay.
so it has to be below.
Your tangent line is based off t equals 0, so it's not
Yeah.
exactly the line that it's at. You're estimating for t equals 3 based off of t equals 0.
So you are doing this like right here, but at 3, you are compare the difference.
Oh, okay.
So if they were asking you for t equals 0, then it would be exact. But since it's based off t equals 0, but they're not asking you for
I
t
see.
equals 0,
Okay.
that's what it's gonna be.
No, that makes sense.
So I hear that we're gonna go to C. C says there is alternative model. Now alternative model is different. If you look at scientific point of view, is t is less than 10. So it's not for t, not accurate if t is greater than 10. So if t is less than 10, it's more. So at first we can probably says, we can probably, we're gonna see what they actually end up to be. But they say t equal less than 10 is because it's more accurate to use this model rather than the other model if t is less than 10. Okay, but so that's, they call it alternative model. So then dg dt is equal to negative g minus 27 to the 2/3. Yeah, so then dg equal to negative 20 g minus 27 to the 2/3 times dt. Now I'm going to divide it g to the other side because I want to separate the g minus 27. I'm going to keep the negative sign on the other side. So negative 1 dt to the 2/3, sorry. Now I'm going to integrate it. Now be careful integrate. This one you don't use natural log because anything to the 2/3 power or 1/3 power has square root or to the 1/4 or whatever. It doesn't matter. If something to the 2/3 power, it's definitely not natural log. Only something parenthesis to the first power and the inside is the first degrees. Okay? Or 1 degree less compared to the numerator. 1 degree more, sorry. So then you just do u equal to g minus 27, du equal to dg. So that's going to be du and u to the negative 2/3 du. And that's going to be integration of negative dt. So this one's u to the 1/3, 3 plus equal to t plus c, negative t, sorry. So it'll be 3 g minus 27 to the 1/3 plus is equal to t plus c negative. Now with that being said, I'm gonna solve for g, so this is just arithmetic. I don't think you have a problem with this. So g minus 27 to the 1/3 equal to negative t over 3. Now the c is gonna be just c. C doesn't divide it by 3. Because c only determined after initial conditions plug in. So then g minus 27 to the negative t over 3 plus c to the 3. And g is equal to negative t over 3 plus c to the 3rd plus 27. And they did say t is equal to 3, approximate t equal to 3. Oh no, they say 0 and 91 still. So I'm going to say 91. And this is going to be c to the 3rd plus 27. C is equal to 4, I believe. So g of t is equal to negative t over 3 plus 4 to the 3rd plus 27. Now I'm going to say g of 3 So g of 3 is going to be -3 over 3 plus 4 to the third plus 27. And that's equal to 54 degrees. As opposed to last time is 43 degree. This one's 54 degrees. So the other one is a module that is for t is going to infinite. Maybe not t equal to infinite, but it's more longer range, longer domain. This one is only specific for less than 10. So the temperature is not decreasing as fast as it does because the other one kind of deviate this one. I don't know if you know what I'm saying.
Yeah.
So, and that's 57, and that is why it's worth 9 point, and that's why its average is 1.4. Last year happened. So first time it happened is 2012. It was a bear question. Everybody managed, like, I think average of that one is 4. Now average of this one is 1.4. And average on the milk question, I have no idea. The milk question is posted online. You can try right now. I don't think it's hard. I think if you understand this question, it's pretty easy.
Is that all this question was asking? Just what is the approximate?
Yeah. No. For this part, they says find an expression of g of t. You're gonna get 4 out of 5 points there, and if you find out the internal temperature of potato t equal to 3. And I remember the meme last year. It was really funny. The meme was somebody post online says my potato temperature is negative 431 degrees. It's like the world's about to end. And that's underneath. And then the kid actually knew like a little bit of, like knew a little bit about chemistry. He's like, that's below absolute zero.
Yeah.
We are gonna we are gonna end. The world's about to end. We're gonna go into the next ice age.
No, I mean, here's the physics class. Like my plane was going like negative 500 miles per hour or something.
Yeah.
Like, funny about that.
I don't know if I still can find those memes, but they were pretty funny.
Wait, did you see your time?
Thank you. Anthony, I saw this problem. It's not hard. No, it's kind of interesting. So every card has a D on one side. On one side.
It's this is a meme that year. 1 potato bacon 90 degree. I just doesn't take AP.
And to check.
Using the food thermometer, touch the banana with bay ham, bite it into a potato, stop the disintegration.
Did anyone get full points on that?
I think so. There are a couple people got a full score. But not a lot of people can get. Yeah, this is the but the best one, it was like an absolute 0 1.
Yep. You can flip over all of them, none of them.
Why don't you click on the pictures?
I don't know if I can click it.
It's really interesting.
I thought I was zooming in.
No.
Those are
I got internally destroyed. And the second question was about banana. It was a banana get off the shelf on the Publix like grocery store. So we're gonna talk about that one on Monday.
I missed it. I'll be honest, I missed this. Have you seen someone in YouTuber Fresh Talwa?
Why?
You should definitely watch it. He makes like math puzzle videos. I know it sounds so nerdy, but
Yeah, send it to me. I love puzzle.
would you wanna?
You seen it before?
He makes really. Yeah, even the name does, but like this is a really cool one. I missed it, but
There was a guy that's my student used to watch. It's called Flammable Math. And this kid was a German physics student, and he just solved like random hard ass math question for fun. And he not only was solve them one way, he was solve this 6 different ways that he can come up with. He's like, okay, let's use the Laplace transform to take integration on this one. And then you can use substitution, you can use trig substitution, you can use this. So he would talk about solving an integral question with 6 different ways, like random way that you can think of.
interesting.
So I have no idea most of the thing he does.
say only 10% get this right.
I didn't go back.
Guys, flip all the cards.
Yeah, but don't worry about these stuff.
No, it's whichever ones to test the rule.
For ultimate necessary.
Yeah, minus. So like, okay, let's start with this. Why do you flip over this?
Look, if they have four, like,
That's wrong, right? Okay.
I don't think I follow definitely.
Now what about 7?
it has a D in this one.
Right.
It
Okay.
has a D in this one.
Or is it wrong? Okay, wait. No,
Wait, can
no.
hit the letter?
I'm sorry. I think I messed up. I think okay, but it's letter and then number.
All that, okay.
Oh, she's very.
So then we do.
Wait, is it every card has a letter on one side and a number on the other?
Yeah, or if this is a letter that's a number, letter number.
So this one doesn't matter if it has a 3 or 4. So K doesn't matter, so it's D. So.
Okay.
Am I on the stream?
Yeah, that's pretty good.
Probably. How do I get out of here?
No,
Yeah, you can only be number.
each card has a number and a letter.